Exercise 3.5 is about zooming. So we will take the bar plots from exercise 2.9 and then use the while function to limit the y-axis. And then some bars will be missing, and the question is why and how we can prevent that. So first we will recreate the plot. So we will read in the data that we used in this plot, and then I can show you how the plot looked like before. Looked like this. And now here we limit the y-axis. You will see here, this is this value here. We will limit it to that. And you can see that here the bars that were over 2 times 10 to the power of 9 high are actually completely missing. And this is because this method of zooming into the plot uses clipping. So the data points were removed, and as they are higher than our threshold here, they are completely removed from the data set, and the bar plots are not plotted in this case. There's also here this warning message that indicates that 3 rows containing missing values or values outside of the scale range were removed. And these are exactly these 3 points here. So this one and these 2 here. We can use an alternative that doesn't use clipping, for example, with the called Cartesian function. And if you do that, you will see here that the bars are still there. Of course, you cannot see their end point, but they are still drawn. In exercise 3.6, we will have a look at axis transformations. So we are taking box plots from before. We use the column log2 intensity to plot the log2 transformed protein intensities. So we did the transformation before. In this exercise here, we will use the original column intensity without log transformation and then apply the log2 transformation within the code of the plot, once using the called trans function and once using the scale while continuous function. And then we will look at the 3 different plots and see what is the difference. So first read in the long format data. So here the first plot is using the log2 intensity column. So this means that we here on the y-axis, the naming of the axis is also log2 intensity, like the column we used. And we see that here also on the axis, the value are already log transformed. In the second example, we will use chord trans with the log2 function here. And what you can see here, the label of the y-axis is just intensity. And you see that also the grid is completely distorted here because it actually writes it in a logarithmic way here. So 2 times 10 to the power of 8 and 4 times 10 to the power of 8 are really close together here in this case. And you have a lot of space for the smaller values. And this also, in comparison to here, changes the way how the outliers are calculated in a box plot. So especially with box plots, you have to keep this in mind that here in this case, actually the outliers were calculated before transforming the axis. So here you see that the box is quite small and here the whisker is really, really long, but it's still not an outlier. And then we will use the scale while continuous function as a third example. And here you can see that you here still have the intensity values and not the log2 intensity values, but the grid is like still equidistant, but you have here the numbers on a logarithmic scale on the different ticks of the axis. So the box plot itself look the same as in the first plot, but just the labeling of the axis is changing. In exercise 3.7, we will look at labeling. So we are taking the PCA plot that we did previously, color the points by group. We will try different options to label the data points. So we will have a look at this. So first read in the PCA data. We can just plot the PCA without labeling once. Looks like this here. And then we will use geom text and label the sample. So we want to know, for example, this data point here in a PCA, which sample it belongs to. At the moment, we only know that this is a control sample, but we don't know which sample. So we use the geom text here, and you can see everything is labeled, but it's maybe not completely nice because actually the label is just at the bot of the data point. So in some cases you can't really read it because too many data points are at the same place. We will then use geom label. This looks really similar, so the position of the labels are the same, but they have this box around them basically. So actually you can't see any data points anymore. And also here, for example, you cannot read the labels of the overplotted points anymore. We will use geom label REPL from the ggREPL package. I think I have to load it before. Here the idea is that they try to have non-overlapping labels. So it takes a bit longer, but you can see here that they try to have non-overlapping labels. They don't overlap with the data points. And if a label is too far away from its original point, like here you have a small line between that, so you can recognize which belongs to which basically. And the last part here was that you can play around a bit with the settings of geom label REPL. So if we have a look at the help page, you can see that there are lots and lots of different options you can use, and you can read what they are doing. Here we will have a look at different things. For example, the nudge is something where you can change the position a bit. For example, on the x-axis, you can change the label size, and here you can, for example, instead of this line here, have an arrow drawn. Yeah, and if we do that, we can see that here the border of the label becomes larger. They tend to be all a bit to the right of the data point now because of this nudge X. And we have here, yeah, a bit too large arrows instead of just lines to point to the data point for labels that are too far away. In exercise 3.8, we will have a look at titles and axis labels, and the task was just to take your favorite plot from before and make more specific titles and axis labels. So in this case, we'll take the box plots that we did. So they look like this here. So what we do with the labs function, we can have a title, which is this box plots. We have a subtitle, which in this case is the data set we are using to create this box plots. We can have a bit more nicer X and Y axis descriptions like sample name and log2 transformed protein intensity, instead of simply having the names of the columns. And the caption is here the data source, or a reference to the paper where the data set comes from. Yeah, when we do this, you can see here you have the title, the subtitle, the axis labels, and here at the bottom you have the caption.